Hey, hey guys, it's Miranda. I'm doing Module 1 Lesson 1, Chapter 1. This is going to be really fun, so let's math it up. Yeah, by me, Miranda Curtis. Yeah, okay. So our first question, it's 1.A, because there's a couple. It says place digital 8, 10, 11, and 12 and 13 in the circles to make the sum across the vertical equal 31. Is there more than one answer to the puzzle? Show all possible combinations of numbers to prove how many combinations exist. Okay, so we have to start with our circles. Okay, we have 12, 8, and 11. Okay, you add all three of these together and you will get 31. Okay, then you do 10, 8, and 13. Again, this will give you 31. There are only two possible combinations to our puzzle. You can sit there and try to plug it in. Plugging in does help when you're doing it on paper. That way you know what's working, what's not working. The best bet is to keep plugging in until you get the right answer. But once you get the right answer, stop. Don't overthink it. Don't go crazy. You'll get it. Okay. So we have it up here. So our possible combinations to our puzzle were 2. And it was pretty simple. We just made sure we had our circles up and had them done. Okay, our next question is part B. Study the same diagram to the right. Note that 2 plus 8 equals 10. So we're going to do side to side, and in the middle is going to be 10. Okay, and then 5 plus 3 equals 8. So again, we're going to do side to side. Okay, and then 5 plus 2 equals 7. So we want to make sure that it equals the top and the bottom equal the middle. Okay, and then this is our little help reminder right here. Okay, this right here is our little help reminder box. It's going to help us solve our problem. Well, we are given, I already have it up here. Yeah, that's right. Okay. We are given 7, 15, 20, 17, and 12 in our bubble down here. This all popped up because it was supposed to go with that one, but it works. Okay, so in our bubble in A, to solve A, this is how we're going to try to solve all the other ones. Okay, A, we are given 7, which is in our blue, 15, which is our white bubble, 20 is in our white bubble, 17 is a white bubble, and 12 is a blue bubble. We have to find what the blue circle is going to be by subtracting. Okay, in order to get 15, okay, we got 7, 15. So 7 minus 15 is 8. And so that's how we got that blue bubble. And then we do the same. And we'll go top to bottom. But 7 plus 8 also equals 15. So you have to go both ways, and it has to do the same or it won't work. Okay, 8 plus 12 equals 20. 8 minus 12 is 12. 8 minus 20 is 12. Okay, so we keep the process up to get the rest of the square. So 12 plus 5 equals 17. Okay, and if you subtract either, that's what you're going to get. Okay, 5 plus 7 equals 12. I've already done the math. I'm just double checking. So A is solved, and we got it all the way around, and that's how we do our addition square. Okay, and B. Okay, 7 minus 13 equals 6. Okay, 4 plus 7 equals 11, and if you do that the other way, it'll be the same. Okay, and the same goes here. 6 plus 15 equals 21. Okay, C was a hot mess, and it did not work. Okay, 9 plus 5 is 15, but 9 plus 3 is not 12. It is 12. But 9 plus 5 is not, that's where it was. 9 plus 5 does not equal 15. That did not work, even though some of your pieces will work. If you're doing it wrong, or if the equation is wrong, like this one right here is wrong, because there's no way to do plus plus, this will get 6, plus plus, that will get 8. That doesn't get 15, but this will get 12. So you know this addition square is wrong. And you also know that this equation, when they ask which one does not equal what it's supposed to, you'll know it'll be C. Okay, now we're going to come over here. 1 plus 6 equals 7. And 8 plus 1 equals 9. 10 plus 6 equals 16. So that was a good one. Okay, here's our next one. Here is, this is problem 2. Okay. It says, on problem 2, it says 9 title squares are laid out on a table so that they make a solid pattern. Each tile must touch at least one other tile along an entire edge. They have to touch. See the 2 examples on your right, which are right here. You have the long one, and then you have the zigzag one. The squares all have the length of 1. So each one is 1. When you count your perimeter, it's going to be 1 for each square. Okay. So RA, it says sketch all possibility figures which can be formed and calculated the perimeter of each figure that can be formed. Okay. The best way I found to solve this is to draw the squares on your piece of paper, because if you make these squares right here, it will help you to visualize if you need hands-on. But if you forget what you drew, it sort of doesn't help you, but it can. But if you draw the figures on your paper, you draw them on your paper, like I did here. You draw them on your paper and you have each one, and you keep going like this until you've done every single one. You will notice there's a pattern within your perimeter. Your perimeter will come out to 12, 16, 18, 14, 20, but you'll notice you'll keep going. And see, that was our formula. That's all the possible figures, 12, 14, 16, 18, and 20. Okay. And then B, which figure has the least perimeter and which has the greatest perimeter. Okay, this one was the least one, was 12, and the greatest was 20. And see, the least one, you just make a big rectangle and you just put them all together. Okay, 20 was laying them all straight out. Here's question 3. Sorry about the dots everywhere. It was a little hard to make those. Okay. This problem 3, and it says, the triangular number and the square numbers are shown below, which, okay, they're there. So triangular numbers, okay, so what it is you have 1 and you have a dot. You have 3, you have a dot. They're in a triangle. I know my triangle are a little wonky. 6, we had dots right here. They're all triangular, and 10 was the same. You had to go up, side, and middle. Okay, its equation was Tn equals n, in quotations, n plus 1 over 2. Okay, and then you come over here, and it's supposed to be a square. I tried. Okay, 1 dot 4 you had to do, and then 9 you did rows of 3. 16 you would do rows of 4 right there. So your equation here in your little cute little cloud, I like the cloud, Sn equals n2. So that is what you would get, because 4 square root would be 16. Okay, now it says consider a new sequence, adopt pattern below to complete part A through C. I know I still have some dots up here, sorry. Okay, we're going to start out with 2 dots. It says first look for your pattern within the number of dots. So we have 2. Okay, I already have this up, sorry, let me use my nose. Okay, so we go to the next one, and we have, okay, just easier to do that one. Okay, First, we're going to start with our dots. First, the dots that we were given, we count them out. You had 2. And then our next dots, you had 6. And then our next dots, we kept going. Because the dots we were given to continue our sequence. Okay. Our dots were 2, 6, 13, and then 22. When you count them all out, that's what you get. Okay, so the next one in our sequence will be 34. I'm gonna go ahead and let them do all that. So I'll explain these. Okay, sorry, let me remind. Okay, so how you get your sequence is what they wanted you to do was to add the next one. This says complete. So the next one we have was 22. We're going to look at right here, we're going to notice that there's a pattern. Okay, 2 minus 6 is 4, 6 minus 9 is 7, excuse me, 9 minus 22, 9 minus 22, or no, 13. Really? Okay, it would be 2, 6, 13, 22. Yeah, wrong. Sorry, I thought I had it right. I had it wrong. It's 13. So what you do is you find your pattern. So with each one, you'll find it's 4, 7, 9. Okay. Now, what's the difference between those numbers? You have to go down to the next one is 3. It's 3. You subtract them, you get 3. So what you're going to do to get your next line in sequence is you're going to take 13, not 9, sorry, 13, and you add 9. Okay, so you have 9. You add 9. And then that will give you 22 dots. Okay, you have to make sure you see I have different colors. You started out with the 2 and then you went around and you got red. Okay, I did the next color. So it'll be easy to differentiate what was our next step. Okay. Now to get down here and you keep going, okay, you'll do 22 and then you'll do its number plus 3. So 22 and you'll have, okay, the difference you'll have is 12. We'll do 12 plus 3, 12, 13, 14, well, 9, 10, 11, 12. So 12, it'll give you 34 dots, okay? See, I have green going around the outside for the extra dots. Okay, then you'll do it again. And then you'll do 12 plus 3, which is 15. And you'll do 34 plus 15, and that'll give you 49. Again, there's a new color on the outside. I'm sorry it got sloppy. The dots just got crazy. I tried to keep it clean, and it just went everywhere. Sorry. Okay, so that is how we're doing this. You want to make sure you look at your sequence, and you're gonna, sometimes it'll jump out at you, sometimes it won't, but keep trying. It's gonna get easier. Just ask questions. Okay, list of the sequence of numbers that corresponds to the sequence part A. They are called pentagram all numbers. Okay, so they're gonna be positive. So you have 2, 6, 9. I did it again. 2, 6, 13, 2, 6, 13, 22, 34, 49. Those are your numbers, not 9. I don't know why. See, I had it right down here in this bubble. See, it says now we're going to look at how the sequence gets. And if you'll look, here's your first row. Here's your little dots right here. Okay, this is their sequence. 4, 7, 9, 12, 15. And then you'll go down, and this is the difference between each one. It's 3, 3, 3, 3, 3. So that is going to be, I think it's a bilateral. Bilateral. So that way it means all the same number all the way across. Now we're going to go to our next question. Okay, so we're going to go to part C. It says, add more equations to this list on the right. The equations are suggested by part A and B. So what we have up here is our example. It says, look, I gotta shift myself side to side because I tried to make it on one side and it didn't work out. Okay, here's the difference. Okay, it says, look for the difference between the numbers. You wanna always look at your sequence. A lot of math is sequence. So you just wanna make sure you're doing good at it. Okay, 1 equals 1, okay? 1 plus 4 equals 5. 1 plus 4 plus 7 equals 12. And then you go 1 plus 4 plus 7 plus 10 equals 22. Okay, when you look at that, what is the difference you can see? Let's see. There we go. Okay, if you're looking at the difference, 1 plus 4 is 5, right? So that's a 3 difference again. Okay. When finding the difference, notice add 3 and you will get the next in the equation. So if we're adding 3 to the last one, we're gonna get 1 plus 4 plus 7 plus 10 plus 13 plus 35. So we're gonna keep on doing that. So after 13, we're gonna get 16. After 16, we're gonna get 19. After 19, we're gonna get 22. And each one, we're gonna keep going by 3s. Okay. Observe that each pentagonal number is the sum of a arithmetic progression. Compute the 10th term in arithmetic progression, 4, 7, 10. The next step to solve D is to keep going with the sequence. We'll give you the answer. Okay, so we went 4, 7, 10, 13, 16, 19, 22, 25, 28. So you know still it's each one is 3. You add 3 to it. And that will equal your answer. Okay. Show the formula for pentagonal numbers and calculate the 9th and 10th term in n terms. So an equals a1 plus d in parentheses n minus 1. And then you have 3n equals 3,1 plus 3 in parentheses 3 minus 1. Okay, our next question is question 4. Okay, question 4 is the figure to the right show, which is over here. It's over here. You see it? Over there. Over there. Okay. The figure to the right shows an additional pyramid in which each number is the sum of 2 immediate below. For each of the incomplete additional pyramids, show the value in each square can be determined by forming and solving an equation in the unknown variable shown. Write an equation to solve each pyramid. Show each step using to solve each equation. So, peoples, this is what we're going to do. I have it written down. Okay. So I went ahead. We're gonna do A. A is so much fun. I love A. Okay. So what we have. Okay. So what we're looking at, and I'm gonna go ahead and follow this in because for some reason it did that. Okay. We need to look at where the exponent is to get our equation. The exponent is in front of the number on the bottom. It will be x to add to the next number. Okay, you look at A, x is in front of 7. Okay, so we're gonna have to x plus 7 is our equation. So what we're gonna do over here to get our square up is 7 plus 3 equals 10, which we were missing. And then what you wanna do is minus 25 minus 10, which is 15, because 15 plus 10 equals 25. You always want these two to equal the next one up. So that's what we did, and we got 25 is up there. Okay, now in order to get x, because x plus 7 will equal 15, what we're going to do is 15 minus 7 equals 8. Okay, and to prove it right, we're going to do 8 plus 7 equals 15. So x equals 8. Okay, and B, it was a little trickier because y was behind 1 So we got to do 1 plus y. I know I should have did a little bit more right there. And really, math is nothing. Okay, so when your number is in front and it's right there next to each other like that, you're gonna plus it. So 1 plus y is our equation, okay? So we're gonna have to figure out something that's gonna figure out this next little square. I know you can't see this next little square that's up there. So what we're gonna do is 6 plus 2 equals 8, okay? Excuse me, 8 minus 15 equals 7. So we're gonna put it right there. So 7 plus 8 equals 15, and that's what we needed. Now, whatever y is, it has to be plus that will equal 7. So what we're going to do is 7 minus 6 equals 1, right? So y has to equal 6. Okay, now we're going to come to c. When the z is up top, like it is right here in the square, it's going to be a minus, because you're going to have to minus that to get to the bottom. Whenever you're going up, it's a plus. When you're going down, it's a minus. Okay, so we're going to do z minus 2, because we have to minus right there. And that's going to give us our equation, c minus 2. And what we're going to do is we're going to come up here. Oh, okay. There we go. Okay, so 8 plus 9 equals 17. We have to plus first. It's right there. I know it's at the bottom. I'm sorry. 8 plus 9 equals 17. So we're going to do that. And then 17 minus 27 minus 17 equals 10. So we're going to have right there. So 10 plus 17 equals 27. What we're going to do is 10 minus 2 equals 8. So therefore, C equals 10. And see, we have our little thing over here. This is how we're going to go by. And this is exactly the same as you're following all the steps. Okay, so we have worked out all of our numbers, and we've gone from top to bottom. And it makes it easier. It really does. Okay, now we're going to go to our next question. Number 5. 5 is fun. I love question 5. I like finding the ones that have the problem solving because it's just fun. Okay, so this is how our thing starts out. It says 4 married couples belong to a bridge club. The wives' names are Kitty, Sarah, Josie, and Ann. Their husbands' names in some order are David, Will, Gus, and Floyd. Use the table below to sort out who is married to who. Okay, so what we're going to do, we have some information. Okay, the first step. Okay, the first step is to read the problem and write down what they told you. So we know four married couples. So we have a table up here. Okay, we have Kitty, Sarah, Josie, and Ann's name up there. Okay, next we have their husbands' names. Not in specific order because we don't know who it is yet. We have David, Will, Floyd, and Gus. So now we're going to write it down and follow our steps. Okay, we're going to start the process of elimination. Okay, they gave us a box, they gave us some information. Floyd is Josie's brother, so we know they married, at least not here. Okay, so next, Josie and Gus dated some, but then Gus met his present wife. So we know Josie and Gus are not married. We got that. Okay, next it gives us Kitty is married to Will. So we know Kitty is married to Will. And we're going to go ahead and cross off everybody else because we know nobody else. Okay, next, Ann has 2 brothers. Okay. But next, we notice Ann's husband is an only child. So that would mean Floyd is counted off because Floyd is Josie's brother. Okay, next, we know about David. And Will is married to Kitty. So we know he ain't married to her. So that means Ann is married to Gus. And it's got to look next. Okay, so we know that Kitty is married to Will, which we could have gone through and marked all those, but I was going to go down the line. So we know Josie and Will are not married. So that means Josie is married to David. And that leaves Miss Sarah has to be married to Floyd. Okay, that means she's not married to David, she's not married to Will, she's not married to Gus. Okay, always read your problem. Always write down what they give you Sometimes they give you too much information and they confuse you. So always write down what you know and look through your problem because it will help you solve it. Now we on to problem 6. Okay. Problem 6. This is going to be fun. Okay. Consider the trapezoidal number 1 plus 1 plus 1, and then comma. Then we got 1 plus 2 plus 2 plus 2 plus 1, comma. We got 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. Okay. The nth trapezoidal number is 1 plus 2 plus dot 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 plus n plus dot 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 plus 2 plus 3. If you keep going down your line, you're going to go 1, 2, 3, and then your n's going to be the next number. Or keep on going. You just keep on going. And your n's always going to be the number that's next, and it's going to be the next ones in your line. Okay, so it's telling us to create a pattern representative of the trapezoidal number. And they're going to be positive because our integers are positive. Okay, we got to start with reading the problem in front of you. Do not overthink it. I did. I promise. The first time I saw this, I freaked out. I overthought this problem. And it's really not hard after you think about it. Look at the numbers. Okay. Look at the numbers and put the dots above it. Like you got 1 plus 1 plus 1 equals 3. So you're going to put 1 dot, 1 dot, 1 dot. And that's going to equal your 3. And that is going to be your pattern. I thought it was way harder. It's not. Okay. Now we're going to look at the next one. I'm sorry. 3rd grade. Okay. We have 1 dot over top, and we got 2, 2, 2, 2, and we got 1. So that's going to equal 8. Okay. Sorry. Again, I try to make them straight. Okay. And then we got 1, 2, 3, 3, 3, 2, 1 equals 15. So you each have your line, and they're going to have that many dots in that line. That's how you're going to do that one. Okay. Notice that 1 plus 1 plus 1 equals 1 times 3. That's a really easy one. Okay, so then you got the same. You keep going up. You got 2 times 4, and you got 3 times 5. Okay, what's going to be cool about this is it's supposed to go up 1 all the way up. 1, you have 1, and you got times 3. Okay, now what you're going to do is you're going to have 2 rows of 4. 2 rows of 4. Okay. Okay, next you're going to do closely the same thing. Now you could do 3 rows of 5. You could, if you're going to do it that way. But you could also do it the same. You have 1 dot here, and you got 2, and you got 3, and then so forth. Oh, sorry, that's not one. Okay. And it really is easy. Okay, guys, thanks for watching my lesson. I hope you learned something. I hope I didn't confuse you. Okay, guys, thank you for watching. Y'all have a good night, okay?